All right, so this is a key on the worksheet on composition of functions. So remember that you can't see it well, but this is open circle. So the little open circle here means composition. All right, so remember by definition, let me go ahead and write that here. By definition, F composed, see that open circle means composed, F composed with G at X. Now that's not multiplication, that's composition. So don't go ahead and multiply. Don't say f of x times g of x. That's incorrect. So composition of functions means that you're going to take g of x and you're going to substitute it inside of f of x. You're going to put it inside of f of x. So by definition, this means f of g of x, just like that. So that's that notation you have to learn. So you take g of x, as that's listed second, as you go in order, that's listed second. You're going to take that, you're going to put it inside of f of x. Okay? Now, whenever you do that, though, you're always going to look at the innermost first. You're always going to look at g of x first, or the inside first, whatever that inside part is. Because it could be f, it could be g, depending on the way it's written here. All right? Okay, so now let's look at this one. So g composed with f at negative 4 using this definition means this. Means g of f of negative 4. That's what that means. Notice the notation. G parentheses f parentheses negative 4 close parentheses close parentheses. Remember, you always do the innermost first. So now we've got to find f of negative 4. So go off to the side and figure out what f of negative 4 is. That's how you do this. Do this little part first. Go off to the side, do the work. Okay, so f of negative 4, we all know how to do that now. So f of negative 4 means you go to your function f, which is this one, and where we see the variable x is substitute negative 4. So that becomes 7 minus 2 times negative 4. So that's 7 plus 8, right, which is 15. So now, see, this is now 15 right here. So now that becomes g of 15. And then finally, to find g of 15, I go to my function g this time, and where we see the variable x, I substitute 15. So that's going to become equal 4 times 15 plus 5. 4 times 15 is 60. 60 plus 5 is 65. And that goes here. Okay? All right, notice the steps that you have to go through. And notice the notation. You have to know by definition what composition meant and how to write it. Okay, now remember, whenever you evaluate either composition or algebra function at a number, you get a number. Here, though, I'm evaluating this at a variable, so I'm going to get a variable expression. Okay, but by definition, f composed with g, that's how you read it, f composed with g at x means f of g of x. That's what that means. All right, now g of x is just this. That's 4 plus x. So in place of g of x, I'm going to substitute 4x plus 5. So that becomes f of 4x plus 5. Okay? Just like you did in the previous exercise, now we're going to find f of 4x plus 5. So now that means I go to my function f, and wherever I see the variable x, I substitute 4x plus 5. So I'm going to go ahead and kind of rewrite it right here. So f of x is 7 minus 2x. So in place of this x, I'm going to substitute 4x plus 5. So now that becomes 7 minus 2 times 4x plus 5. And then using the order of operation, I'm going to go ahead and distribute negative 2. So I get 7. A negative 2 times 4x is a negative 8x. A negative 2 times 5 is a negative 10. Now before I go on, there's still a handful of you that get a little confused here. You want to say 7 minus 2 is 5, but remember, order of operations, you have to multiply before you subtract. So that's why you don't say 7 minus 2 first. You have to say multiply and then add that 7 to it, like you see here. Combining like terms, I get negative 8x, so equals negative 8x. 7 and a negative 10 is a negative 3. So that goes here. So negative 8x minus 3. All right. Okay, number 2, this time, so number 1, though both of those were linear functions. Here, one's quadratic and one's linear. Okay, but the idea is the same, the work's the same that you did with number 1. So f composed with g at 1 by definition means, and you have to write this, you have to show this. So you have to show this, you have to show this. Okay, it's very important. You do the work as required. So by definition, this means f of g of 1. All right, now we got to find what g of 1 is. So I'm going to go off to the side, and I'm going to figure out what g of 1 is. So to find g of 1, that means I go to my function g, which is this one, and wherever we see the variable x, I substitute 1. So it becomes 7 times 1 minus 1, just like that. 7 times 1 is 7. 7 minus 1 is 6. So g of 1 is 6. So in place of g of 1 here, I'm going to substitute this 6 that I just found it to be. So now f composed with g of 1 then is equivalent to f of 6. And then we all know how to find f of 6. F of 6 means I go to my function f, and where we see the variable, I substitute 6. So that becomes 2 times 6 squared minus 3 times 6 plus 1. 6 squared is 36. Order of operation, you got to do the exponent first. 36 times 2 is 72. Minus 18 plus 1, right? And then using a calculator, you'll say 72 minus 18 plus 1 equals 55. So 55 goes here. So remember, whenever you evaluate a function at a number, you're going to get a number. Whenever you evaluate it at a variable expression, you get a variable expression. So over here, now I'm going to find g composed with f at x. I'm going to get a variable expression. So let's go and do that work. So by definition, g composed with f at x, and you have to write this, you have to say g of f of x, just like this. Parentheses, 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 parentheses. Then we know what f of x is. Always do the innermost first. We know what f of x is. F of x is this quadratic function right here. So that becomes g of 2x squared minus 3x plus 1. And then now I have enough information to where I can find g of 2x squared minus 3x plus 1. So g of f of x is equivalent to saying g of 2x squared minus 3x plus 1, because that's what f of x equals, right? Now we're going to find this. We're going to find g of 2x squared minus 3x plus 1 by going to my function g. And here's my function g. Let me go ahead and rewrite it. There's my function g. And wherever we see that variable x here, I'm going to substitute this quadratic expression. And so now this becomes 7 times, and then in place of this x, I'm going to substitute that trinomial. So 2x squared minus 3x plus 1, and then minus 1. Now distributing, going to simplify this. 7 times 2x squared is 14x squared. 7 times a negative 3x is a negative 21x. 7 times 1 is 7, and then minus 1. Combining like terms, I get 14x squared minus 21x. 7 subtract 1 is 6. And so that's it. So that's going to go here. So g composed with f at x is this quadratic expression right here. So 14x squared minus 21x plus 6. All right? Okay, so that is the key to the worksheet on composition of functions.